In this video, I want to go over section 3.1 of Introductory Statistics in OpenStax. All chapter 3 is talking about the probability, and section 3.1 mostly talking about the probability terminology. So what's a probability experiment? Probability experiment is a planned operation under some controlled conditions. Like when you flipping a fair coin, that's a probability experiment. When you roll a fair dice, that's a probability experiment. And what's the outcome? The outcome is the result that we get for every single trial in any probability experiment. For example, when we flip a fair coin, we get heads or tails. Head and tails are the outcomes. When we roll a fair dice, we may get 1 or 2 or 3 or 4, 5 or 6. Numbers 1 through 6 are the outcomes, the result of every single trial. So what's a sample space? A sample space is when you put all of the possible outcomes that we may have in the probability experiments in a set notation. For example, we said that if we flip a fair coin, the outcomes that we may get is head or tail. And if I put head and tail in a set notation, we call this one a sample space, and we show by letter S. Letter S tells me that's a sample space. All possible outcomes. When you roll a dice, all possible outcomes are number 1 through 6. So you can show the sample space by putting numbers 1, 2, 3, 4, 5, and 6 in a set notation. Now that's a sample space when you roll a dice. An event, it consists of one or more outcomes, which is usually a subset of sample space, because we said the sample space is all possible outcomes. But when I find, for example, the probability to get heads, when I flip a coin, getting a head is an event. And that event, it's a subset of the sample space, because sample space consists of both of head and tail. Or when I roll a dice, the event, one event can be just getting a number less than 4. That's an event. Numbers less than 4 on the dice are just 1, 2, and 3. And as you see, those are all in sample space. That means that event is a subset of the sample space. We usually show the events by the capital letter, like event A, event B, and we need to define each of these events in just defined a notation for any event that we want to find the probability for. Okay. So let's look at an example. It says find a sample space for the experiment of flipping a coin and rolling a dice. Okay, this time we want to flip a coin and roll a dice at the same time. So you want to write the sample space. That means you want to write all of the possible outcomes. When you flip a coin, there are 2 possible outcomes, head or tail. When you roll a dice, there are 6 possible outcomes, numbers 1, 2, 3, 4 to 6. Now, I want to find a sample space for the experiment that has both of them together, flipping a coin and rolling a dice at the same time. So the easiest way to find all of the possible outcomes is showing a 3 diagram. When you flip a coin, I said there are 2 possible outcomes, head or tail. You may get head, and when you get head, then you roll a dice. When you roll a dice, you may get 1, 2, 3, 4, 5, 6. Or you may get tail when you flip a coin, but still when you roll a dice, you have all the possible outcomes of 1 through 6. And the 3 diagram help me to complete and find all of the outcomes of the sample space. And as you see, The first one is for the coin. This is for the coin. And these are for the dice. And these are all of the possible outcomes. That means getting a head on the coin, and 1 in the dice. Getting a head on the coin, 2 on the dice. Head on the coin, 3 on the dice. Head on the coin, 4 on the dice. And if I put all of these outcomes in a set notation, now I will have my sample space. So 1, tail 2, tail 3, tail 4, and tail 5, tail 6. These are all the possible outcomes. And I show the sample space usually with letter S. And as you see, the sample space in this event, in this experiment, has 12 outcomes. And that makes sense because when you flip a coin, you have 2 outcomes. When you roll a dice, there are 6 outcomes. And if you multiply them together, 2 times 6 must give you 12 outcomes. And now I have all 12 outcomes in my sample space. And each of these are called an event. Event, the first event, another event, another event. Okay? When we have a simple event, whenever you have an event that consists only one single outcome, you call it a simple event. But if it has more than one, it's not a simple event. For example, when you, in a previous example, you flip a coin and you roll a dice. And if you define the event A is getting a head on the coin and 3 on the dice. How many of these outcomes had head and 3? Just one of them. So the event A only has one outcome. Is this a simple event? Yes. But if I want to get a head on a coin and getting an even number on a dice, when I look at the sample space, how many of these outcomes had the head on the coin and even number on the dice? So when I look at the all possible outcomes, I see head, this one, and an even number, head, an even number, head, an even number. So event B has 3 outcomes, H2, H4, and H6. Is this a simple event? No, because it has more than one outcome. Next example, it says determine the number of outcomes in each event and then decide whether it's a simple or not. It says for quality assurance, you randomly select a machine part from a batch that has been manufactured that day. Event A is selecting a specific defective machine part. Is this a simple event? When you only select one machine part, and event A is selecting the defective machine part, that means event A has only one outcomes because you only picked one machine part, one defective machine part. So we say, yes, that is a simple event because it only has one outcome. Next example, it says you roll a 6-sided die and event B is rolling at least 4. So if you want to write all the outcomes in event B, when it says event B is rolling at least 4, at least means minimum. Minimum must be 4. That means it can be 4 or more. And all the numbers on the dice that are 4 or more are 4 and 5 and 6. So event B can be 4, can have 4, 5, and 6. So it has 3 outcomes. Is it simple event? No, it's not a simple. When we find the probability of any event, first of all, we show the probability by letter P, the capital P. P represents the probability. And we always find the probability for an event. An event, usually we show the events by capital letter A, B, C, D, E. It depends on the problem. We just give it a name. When you find the probability of event A, or you want to find the probability of A or any event, just have to remember that the probability of any event is always a number between 0 and 1. When we have a probability of an event 0, when that event is impossible to occur. When do we have a probability of an event 1? When that event 100% occur. We may have any number between 0 and 1. And whenever we have 0.5 for the probability of any event, that means there is a 50-50 chance of occurring. Okay? But remember, that's important that when we get to the rest of the chapter, anytime you find the probability, if you see that the probability of any number is negative, that means something is wrong. You cannot have a negative as a probability. If you see that the probability is the number more than 1, again, something is wrong. The probability of any event must be a fraction or a decimal, which is between 0 and 1 only. So as I said, we only get 0 when that event never happened, when we get 1 when that event always happened, and we get 0.5 when that event is equally likely to occur or not occur. For example, when you flip a coin, there are 50-50 chance of getting head or tail. That means head or tail are equally likely to occur. So that means the probability of getting head is 0.5 or is 1/2. Or the probability of getting tail is also 0.5 or the 50% chance of getting a tail and a coin. We have 3 types of probability that we want to discuss. The first probability that we find is called the classical probability. How do we find a probability? We need to find the number of outcomes in that specific event and then divide it by the number of outcomes in sample space. Okay. For example, when we roll a 6-sided die and A is rolling a 3, getting a 3, so you want to find the probability of that. And to find the probability of event A, we need to know the number of outcomes in event A divided by the number of outcomes in sample space. So that means I need to find the sample space. To find the sample space is all possible outcomes. When you roll the dice, all possible outcomes are numbers from 1 to 6. And the number of outcomes in the sample space is 6. We have 6 outcomes in sample space. Now, when I say I want to get 3, how many 3 do we have on a dice? What's the number of outcomes in event A? There's just 1 because we only have 1 3 in the dice. So the probability is 1/6. To roll a 7. Again, I need to have a sample space, which I have it. Sample space is always the same for all events in that experiment. Now, how many outcomes do we have in event B? How many number 7 do we have in a dice? Nothing, 0. So that means the probability is 0/6, which is 0. Okay. And the last one is the event C is rolling a number less than 5. You need to find the number of outcomes in event C. Okay, how many number less than 5 do we have in a dice? We have 1, we have 2, 3, and 4. How many? 4. 4/6 because the sample space is 6. So 4/6 or 0.667 is the probability of getting a number less than 5. Another types of probability is called the empirical or statistical probability. These types of probability is when we find a probability based on the observation, and that is exactly the same as the relative frequency of any event. If you remember the relative frequency, for finding the relative frequency, we said that we have to divide the frequency of that class by the total frequencies. And we do the same here. We find the frequency of that event and divide it by the total frequency. And we usually use these probability, these types of probability, when we have an experiment which is repeating. And the last type of probability that we have is called the subjective probability. Subjective probability is just an estimate. It's just a guess, an educated guess. There's no formula to calculate that one. For example, it says a doctor may feel that the patient has a 90% chance of a full recovery. How doctor get that number? Based on it's just an estimate from the doctors, right? And it comes from the previous study or the previous patient that has understood. That's kind of educated guess. That's it. We don't have any formula to find that one. Let's look at this example. It says classify this statement and tell which one is a classical probability, which one is empirical, and which one is subjective probability. First, the probability that you get an A on your next test is 0.9. So getting an A on the next test, so it's just an estimate because we don't know what will happen, right? And that's just an estimate based on the previous, grade that we have on that class. So it's just an estimated or kind of educated guess. That's right. It's just a guess. So that is a subjective probability. Next example is that the probability that the voter has chosen a random will be younger than 35 years old is 0.3. Okay, it's talking about a voter's age, and it says that the probability that the voters are younger than 35 is 0.3. So to find this probability, we usually need the kind of observation, observing, the voters or surveying the voters and see what's the age of the voters. That's right. So when you survey or you find the numbers based on your observation, that is called the empirical probability. It comes based on the result of a survey or the frequency of the voters. And the last example is the probability of winning 1,000 ticket raffle with one ticket is 1/1,000. We have 1,000 ticket raffle. We have only one ticket out of the 1,000 ticket raffle, and the probability is 1/1,000. The number of outcomes, number of sample space. That is the formula. It's coming from the formula. That's right. So that's a classical probability. Let's look at next example. It says there are 23 countries in North America, 12 countries in South America, 47 countries in Europe, 44 in Asia, 54 in Africa, and 14 in Oceania. A is the event that the country is in Asia. E is the event that the country is in Europe. F is the country is in Africa. N is the event that the country is in North America. So we want to find the probability of each of these events. To find the probability of A, so we know that the probability of any event, for example, the probability of event A is the number of outcomes in event A and the number of outcomes in sample space. What's a sample space? Sample space is the set of all possible outcomes. In this example is the total number of countries that we have. How many countries do we have? 23 in North America, 12 in South America, 47 in Europe, 44 Asia, 54 in Africa, and 14 in Oceania. And if I add them all together, I get 184. That's a sample space, the number of outcomes in sample space. Now, when I want to find the probability of A, okay, A is the event that the country is in Asia. The number of outcomes in event A. The number of countries in Asia. How many countries do we have in Asia? 44. So the answer is 44 over 184. Number of outcomes in sample space. Can I simplify? Yes, I need to simplify. And when you simplify a fraction, remember you divide both top and the bottom of a fraction by the same number. And if I divide both by 4, I get 11 over 46. To find the probability of E, the probability that the country is in Europe, I need the number of countries that's in Europe, which is 54 countries in Europe, divided by the sample space, which is one. Europe is 47. So 47 divided by 184. I don't think we can simplify this one. And the probability of N is the number of outcomes in event N, or that means the number of countries in North America. And in North America, we have 23 countries. So the answer is 23 over 184. The complementary events. Complement of any event is the set of all outcomes in sample space that are not in that specific event. We said that the sample space includes all possible outcomes. If event E is a subset of the sample space and has only, for example, in this example, has only 3 of the outcomes. So that means the remaining of the sample space is in event E prime. Okay, so that means E prime, or the complementary event, or the complement of event E, it's all of the outcomes that are in the sample space but are not in event E. And based on that, the probability of any event adding with the probability of its complement is always equal to 1. Because any event and its complement usually contains all of the outcomes in sample space. So how this formula can help me? This formula tells me that if I move one of them to the other side, the probability of one event is this 1 minus the probability of its complement. And we need to know that because sometimes to find the probability of some events, finding the complementary event is much, much easier. So we can find the complementary event and then subtract it from 1 to get our answer. For example, it says, find the probability of randomly selected social networking site user who is not 25 to 34 years old, not 25. So when it says it's not 25 to 34, that's 25 to 34, that's right? Not can be in this group, or in this group, or in this group, this group, this group, and this group. That means I need to find the probability when the user is 13 to 17, or 18 to 24, or 35 to 44, or 45 to 54, or 55 to 64, or 65 and over. That's right. You need to find the probability for all of them because it says it's not 25 to 34. When it's not 25 to 34, it can be any a part of any of those classes. But I believe that if I find the probability for 25 to 34 and use the complementary event, is much easier for me because I only need to calculate the probability of this group, 25 to 34. And to find the probability, I know that I need to divide the frequency of that class divided by the total frequencies, which is 3,000. So 765 divided by 3,000, that is the probability if the user is 25 to 34. But now, after finding that, if you want that the user is not 25 to 34, we use the complementary event and then subtract that number from 1. And you see that it's much, much easier than just using all other classes instead of just 1. And that is the final answer. The law of large numbers tells us that when some procedure, some probability experiments is repeating again and again, the relative frequency of that probability usually approaches the actual probability of the event. Okay, so we said that the empirical probability using the frequency of the event. And we usually use the empirical probability when we have an experiment which is repeating and repeating. And that the law of large number tells me when repeating many times, the empirical probability, it's exactly the same as the classical probability. The frequency probability of that event approaches the actual probability. And that only works when we have large number of trials, not very small, okay? It doesn't apply for one individual outcome. It's usually when we have experiments that are repeating a lot. Let's see what's or an and event. Sometimes when you want to find the probability of an event, we have an or. For example, they tell us find the probability of event A or event B. What does it mean, or? Or means you need to add. You need to combine all of the outcomes in event A and event B, because A or B means all the outcomes, which is in event A or in event B or in both. For example, if event A is are numbers 1, 2, 3, 4, 5, and event B is number 4, 4, 5, 6, 7, 8. When I say A or B, that means I combine all of the A and B. I put all together. I put all of the events A and events B in one set notation. Event A, 1, 2, 3, 4, 5, and event B, 4, 5, 6, 7, 8. 4 and 5 is repeating in both of those events. But I'm not going to repeat, you just write them two times in when I'm writing the A or B. So if you see same numbers or common numbers between the two events, you just need to repeat them once. Okay, and you have to make sure that they are not listed twice. So A or B are 1, 2, 3, 4, 5, 6, 7, 8. All of the A with all of the B. But when we talk about AND event AND means only the outcomes that are in both A and B at the same time. If A is 1, 2, 3, 4, 5, if B is 4, 5, 6, 7, 8, what numbers are in both? 4 and 5. So A and B is just 4 and 5. Okay? Let's look at an example. It says in a bag there are 6 red marbles and 4 green marbles. The red marbles are marked with the numbers 1, 2, 3, 4, 5, and 6. The green marbles are marked with numbers 1, 2, 3, 4. R is the event of getting a red marble. G is the event of getting a green marble. O is the event of getting an odd numbered marble. So that's a sample space. How do we find the sample space? So we have red marbles, which they are marked with number 1, 2, 3, and 4, and 5, which means R1, R2, R3, R4, and R5 are the sample space are just all the outcomes for red marbles. It says green marbles marked with 1 through 3, 4, which means G1, green 1, green 2, green 3, and green 4. And if I put them all together, it gives me the sample space, all possible outcomes that we have. That tells me R1 means tell me a red marble with number 1, a red marble with number 2, green marble with number 2. Now it's asking you what's the probability of G and O. G means getting a green marble. O means getting an odd numbered marble. And I know and tells me they must occur at the same time. So that means I only write the outcomes out of the sample space, only outcomes that have a G and odd numbers at the same time. Green and odd numbers. Okay, green and odd number, green and odd number. That's it. So the answer, for outcome G and O, if you want to write the outcome, it says G and O only has two outcomes, G1 and G3. But if you want to find the probability, make sure that you have a fraction for the probability. And when you find a probability, we put the number of outcomes in the event on the top, the number of outcomes in the sample space at the bottom. How many outcomes do we have in event G and O? Just 2. How many outcomes do we have in the sample space altogether, which is 10. It's 9, sorry. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I missed 1. I missed 6 here in my note. Okay, that's awesome. Yes, that's 10. So it's 2 over 10, which is if I simplify, I get 1 over 5. I was just looking at my writing. It was missing 1. Okay. So the probability of receiving green marble and odd number marble is 2 over 10, which is 1 over 5, or 1/5. What's the conditional probability? Conditional probability of A given B, which we usually write in this form. And to read this one, we say the probability of A given B. That line is just will be read given, which means you want to find the probability of A when the B already occurred, when B is already given to you. You know that the B occurred, and now you want to find the probability of A. But you have to be careful because sometimes occurring B affect A. Sometimes it doesn't, sometimes it does. So that's why we call it a conditional probability. Finding the probability of A with the condition that we know B already occurred. Okay? And to find this probability, we need to know the probability of A and B, and then divided by the probability of B in this example. But if it's probability of B given A, we need the probability of A and B divided by the probability of A. A means the given part. If it's A given B, it's probability of A and B divided by the probability of B. You always divide it by the probability of that event that already occurred. Okay, let's look at an example. It says, suppose we toss one fair six-sided dice. Okay, when you roll a dice, the sample space is all the numbers from 1 to 6. Event A is facing 2 or 3. Event B is facing an even number, like 2, 4, and 6. So event A is just 2 or 3. Event B is getting an even number, which is 2, 4, and 6. And you know all of these events are the subset of the sample space, okay? Now we want to find the probability of A given B. We want to find the probability of getting 2 or 3 when B already occurred. Okay? That means when we know that we have an even number for trust. So to find this one, We need the probability of A and B and divided by the probability of B. Probability of A and B. We said that and means both of them must occur at the same time. When we look at the two events of A and B, what numbers occurring in both? What number is common in both of these two events? Is 2, right? So it's just 2 is in common between these two events. So that means the probability of A and B, it's just one number out of the 6 number that we have in the sample space. Whenever you see P as a probability, you must have a fraction. To find the probability of B, find the probability of having an even number. Okay, we just look at event B. How many outcomes do we have in event B? 3, and divided by the sample space, which is 6. And if I divide 1/6 by 3/6, if you ask, okay, how can I divide them? You can change your writing in this form. Instead of saying 1/6 divide by 3/6, you can say 1/6 divide by 3/6. And dividing the fraction requires keep the first fraction the same, flip the second fraction, and change it to multiplication. Then, if you can simplify a number from the top and the bottom, we do that, and just multiply across the remaining, which is 1/3. Or you can also, instead of using the formula, you can just find probability of A given B. We said we want to find the probability of A divide when the B is already occurred. Okay, so that means when B occurred, B only has 3 outcomes. And out of those 3 outcomes, we want to find the probability of A, probability of getting 2 or 3. Okay, out of these 3 outcomes, can you tell me how many of them are 2 or 3? Just one of them. So out of those 3, I only have 1, so it's 1/3. We can just find without using the formula. Let's look at this example. This table describes the distribution of a random sample S of 100 individuals organized by gender and whether they are right or left-handed. Event M is when the subject is male, F is when the subject is female, R the subject is right-handed, L means the subject is left-handed. And we have the number of males that they are right-handed, the number of males that are left-handed, the number of females that are right-handed, the number of females that are left-handed. I have a table. And if I ask you, okay, how many males do we have in this table? How many males do we have? Add all of the males row. 43 plus 9, which is 52. So we have 52 males, all right and left-handed one together. How many females do we have? All 44 right-handed plus 4 right-handed, that together is 48. So if you want to read this table, you need to know that there are 52 males and there are 48 females, that together gives you the 100 individuals. So these 100 is a number of sample space. And since you know to find every probability, you need to divide the number of outcomes and then divide it by the number of sample space. So the denominator of all of this fraction must be 100, because the sample space includes 100 outcomes. When it asks us find the probability of M, find the probability when the subject is male. Okay, so let's look at this table. We need the number of males and divided by the number of sample space, which is 100. How many males do we have in this table? Males together are all 52. So it's just 52 over 100. You need to simplify as well. What's the probability of R? Probability of R means the number of right-handed Divide by the sample space. Sample space is 100, I know. How many right-handed do we have? It doesn't mention male or female, just right-handed. We have 43 male right-handed, we have 44 female right-handed, so that means right-handed together are 87. So that means the probability of having, when the subject is right-handed, is 87 over 100. Okay? Now, find the probability of M and R. And means occurring at the same time. We want to find the probability when the subject is male and also is right-handed at the same time. How many male that are right-handed are in the table? Males, right-handed. How many? 43. So we have 43 over sample space, which is 100. Now, part D, find the probability when we have the subject is female and left-handed. How many female that are left-handed are in this table? Females that are left-handed, there's just 4. So the answer is 4 over 100. Part E says find the probability when the subject is male or right-handed. This time we have or. Okay, we said or means adding all together. That means adding all of the males and adding all of the right-handed people. How many males do we have in total? 52. How many right-handed do we have in total? 87. So that means I need to add 52 by 87. All the outcomes and divide it by 100. But if I add 52 and 87, for sure, I get a number more than 100. And 100, if it's a number more than 100 divided by 100, your answer should be a number more than 1. But I know the probability of any event must be less than 1. Why we have this? Because we double counted some people. There are some peoples, there are 43, you see the intersection of these two, there are 43 people that are male and right-handed, and you count them two times in when you are adding these two numbers. Because those 43 are in 52 males and also are in 87 right-handed. So I don't have to double count any. So if it's double counting, make sure to subtract them that they just counted once. Now the final answer, 52 plus 87 minus 43, it gives me 96 over 100. So that means there are 96% chance that we have a male or a right-handed person. Next part, find the probability when we have a female or left-handed. Or means all together. How many female do we have? How many females do we have in total? We have 48 females. How many left-handed do we have in total? 9 plus 4, which is 13. But I see there is an intersection between these two, which is 4. 4 of them are double counted. Then they are in both groups. So I need to subtract those 4 without counting them 2 times. So now 48 plus 13 minus 4 is 57 over 100. What's the probability of M prime? M prime is complement of event M. I have an answer for event M, the probability of M. And whenever I have the probability of any event, find the complementary is easy because I can only subtract it from 1. So the probability of M prime is 1 minus 52 over 100. And if I subtract these numbers, I get 48 over 100. That's it. You don't need to find it. Next part, we want to find the probability of R given M. We want to find the probability of when the subject is right-handed, and given that that subject is male. That means out of the males group, you need to look for the right-handed one. That's right. How many male do we have? Because that's a given part. How many male do we have? 52. So that this time your sample space is 52 because you know that that's a condition. You just find the right-handed one out of the male group. The male group are only 52. And out of those 52, how many of them are right-handed? 43. So the final answer is 43 over 52. Or you can also use the formula to find the probability of R given M. You can use the formula, that means find the probability of R and M and divide it by the probability of M. R and M means right-handed and male. So right-handed and male together are 43 out of 100, the sample space. The probability of M, the probability of males, how many males do we have? 52, so 52 over 100. And if I divide these two numbers, I get 43 over 52. Or you can just look at the male part, male group, which is 52, and find the right-handed one, which is 43 out of 52. For the next one also, we have a conditional probability. We want to find the probability of female given left-handed. When it says given left-handed, that means the left-handed is your sample space. Out of the left-handed one, we want to find the probability of female. How many left-handed do we have together? 9 plus 4 is 13. So we have only 13 left-handed. And out of these 13 subjects, how many of them are female? Just 4. So it's 4 over 13. Or you can also use the formula, the same as part H. And I will leave this one for you to find the answer.